I'm Max Spiller with Maddox, and this is how transformers work. For context, let's see the journey electricity takes from the power plant to you. The core function of the transformer is to convert power from low voltage to high voltage at the power plant for transmission, and then lower it back down for distribution. This thermal energy plant uses steam to spin a turbine connected to a generator to translate the mechanical energy from the spinning turbine into electrical energy. The process produces large amounts of electricity, but at relatively low voltage. So the power must be transformed to high voltage for transmission. Every power plant has at least one step-up transformer, which boosts the voltage to get the power across long distances. As it arrives at its destination, the power must be transformed back to low voltage for use by another transformer. Let's take a closer look at how it works. High voltage bushings connect the transformer to the power source. The core and coils are the heart of the transformer. Current flows from the power source into the primary coils. The current flowing through the coils generates a strong magnetic field, which induces a current into the second set of coils located inside the first. This process is called induction. The ratio of loops in the primary coil to that of the secondary coil is what determines the voltage the transformer converts the power to. In this example, our primary voltage is 12,000 volts, and our secondary voltage is 480 volts. That's a ratio of 25 to 1, meaning for every 25 loops in the primary coil, there's one loop in the secondary coil. The coils are looped around a special steel core, which picks up the magnetic field from the primary coils and strengthens it for better induction. A special rotary switch is used to manually disconnect the transformer from the power source as needed. These types of switches are called load break switches because they can function even when the transformer is energized and under load. Fuses protect the electrical system in the event of an overcurrent situation. When exposed to high current or high heat, a thin wire within the fuse, called the element, melts, effectively opening the circuit and disconnecting the transformer from the power source. Once the issue that's caused the fuse to blow is resolved, the fuse can be removed and replaced. Voltage adjustment taps allow you to maintain the correct secondary voltage in case the primary voltage is higher or lower than expected. The tap setting on the transformer is adjusted by rotating the tap changer. As the tap changer is rotated, small sections of the primary windings are disengaged, which alters the ratio of primary to secondary windings, thereby lowering the primary voltage rating. Transformers heat up during operation and need a cooling system to keep the temperatures down to ensure proper function. To do this, the tank is filled with special fluid, which acts as both an electrical insulator as well as a coolant. A nitrogen blanket is added to the empty airspace remaining in the tank, which prevents contaminants like oxygen and moisture from entering the fluid. The coils are wound with spacers between each layer of windings, creating channels called ducts. The fluid flows through the ducts, pulling heat away from the coils along the way. As the fluid rises in temperature, it rises to the top of the tank. It enters the radiators, where the ambient temperature cools it off. As the fluid cools, it drops to the bottom of the radiators and re-enters the tank. This process is called natural convection. Some transformers come with fans which blow cool air through the radiator fins, speeding up the cooling process. Gauges are used to monitor operating conditions. The liquid level gauge monitors the level of the fluid inside the tank. The thermometer measures the temperature of the fluid, and the pressure vacuum gauge monitors the amount of pressure inside the tank. The low voltage bushings connect the load to the transformer. In this presentation, we use the example of a liquid-filled pad mount transformer. Although they come in many shapes, sizes, and styles, the purpose remains the same. From power generation, transmission, distribution, and delivery, transformers provide us with the electricity we need to go about our daily lives.